אז צהריים טובים. Anybody that doesn't speak Hebrew? Okay, so I'll switch to English. אבל תדעו שיכולתי בעברית גם, כן, התכוננתי עבורכם. So my name is Raphael, I'm the head of research in Chorus AI, and I'm going to talk to you today about punctuation. So you get a taste of that with the little clippy over there that already knows how to punctuate. So what's punctuation? Let's start with understanding the problem. So this is a research abstract from 2015, and I'll just release this. Yeah, so we can see that on the top we have the abstract without any punctuation marks. Nothing is capitalized, and generally it would probably take you a few extra microseconds to read it. While the punctuation on the bottom would help you understand much faster what is happening there. You can see that on the bottom there is a list because there are a lot of commas. Question marks indicate that someone is asking a question. And the text itself, if you read it, explains to you what punctuation is, taking and restoring these punctuation marks. So why would we want to do that? Don't we have punctuation marks? So what kind of data are we working with? We're a conversation intelligence company, and we help people capture the conversation, transform them into data, and get better at them. For us, it means whenever your company is communicating to your customers, you're actually creating data, and you might be losing that. So we want to help you get better on various tasks, like training. Are you conducting your meetings in the right way? For sales, it takes months to get somebody to know how to sell your product. If you can cut it down by 50%, they would sell your product an extra 3 months. So that's an extra quarter of sales per person. Adopting messages, having effective one-on-ones. We want to be able to see what kind of meetings people were having and give them feedback. Better handoffs, capturing what customers want. If customers keep saying that they want us to integrate with Microsoft Teams, we can just switch from hearing that somebody asked about Microsoft Teams or having some salespeople that are pushing for that more strongly because it appears on their leads, to simply searching all of the conversations that happen in our system and knowing what people care about. And in general, where the field is going, I believe that in the future, everybody should record their meetings. Some organizations have 50% of their time spent on meetings. Getting better at meetings can really drive up productivity, and it's one of the next big things in productivity. What does the system look like? And I promise it's going to be, the sales part is going to be short, but I do want you to understand what we do. So we're not an ASR company, we don't just transcribe. So we can see what a deals looks like. So we can see Katrina, who is one of our top salespeople here, and she's talking to someone, and we can see the entire history of the interactions, that there is a customer named A that she talked to 38 times, and we can see their emails and identify what are the next steps, what are the risks, what are the questions, did competitors come up, what do they care about. So as her manager, I could go into the deal and see, is it healthy? When was the last time they spoke? Did they raise any objections? Are they talking out about the competitor? What is the chance that she's going to close this? Maybe I can bring extra help. Maybe I can rope in more sales engineers to help in this deal. So it allows us to do a lot of things, an X-ray of the meeting if you'd like. Another thing that we can do is identify what's on screen. So you have your deck, and you can see me on the screen there practicing for this deck, and of course we captured that in Chorus. And afterwards I can jump to different parts of the deck. If you look at the bottom half, we identify which images on the screen are identical, and I can just jump around or search with the specific deck if it's a sales deck and see how all the best people sold with it. So if you look on what I'm showing on the screen, it's actually someone showing this screen in Chorus of himself doing a demo in Chorus and sharing that. So we have 3 layers of inception. So what happens in Chorus? Just for the background, I want you to understand why are we doing punctuation. We capture all of your conversations. If you know engineers, send them our way. It's big data, 15 million hours of calls. I'll jump ahead. And then we have an entire tech stack that is supposed to turn them into all the data that we've seen in the product. So it's not one classifier, it's not just transcription or just understanding vision. We have this entire stack that we need to solve a lot of small different problems, most of them with AI, in order to get that product perfect. So we identify speech, we transcribe it. There was a talk here earlier about how to do transcription and how to identify their own words by our competitors. We want to make it readable, and this is what I'm going to talk about today, because if you just show people the plain transcription as you get it out of a transcription system, they are not happy. We found that out, having our first customers. It's ugly, it's unreadable, they don't know what to do with it. We have other tasks, some of them I mentioned in this meeting last year, but I'll jump ahead. So I promised you a short marketing thing, and now we're back to punctuation. So just a reminder, we have this paper from 2015, and it's by Tilk and Tunnel, and they had a great piece of software that does that. So actually what we're going to talk about today is revisiting a problem that we already solved. So 4 years ago, we found out when we deployed systems to our first customers that people want punctuation. They can't read it. They say, you have a lot of errors, but actually it turns out that what they want is the text to be readable. So our objective here is to replace something we already have in our system, which is working, which is slightly different than approaching a problem that we've never solved before. So we deployed this 4 years ago. We have a lot more tag data than we had back then. The old model was Theano-based by Tunnel. Basically, the AWS Dockers, they don't support Theano well anymore, so it's even hard to upgrade the software. We wanted to support other languages, so we had to add and train more models, and we really didn't want to use that old Theano model anymore. In their paper from 2015, they wanted to incorporate speech cues, which I'm going to describe later, but we did not do that in our first model because we didn't have enough data to train a meaningful model. So we wanted, while we're revisiting this thing that is living in our system, to already improve it. And somebody sent us, one of our speech advisors told us, hey, there is this new BERT model going on, why don't you look at it? Because, that's what people say. Okay, so let's talk a little bit about our journey. הטכנאי שאל אותי מה עם עידו. He didn't come today because he's sick, but he loves BERT. And so we start our mission. We see that there is an online BERT repository that is doing punctuation, and they are promising us that it's much better than that old Theano Git that we had before. So we download it, we run this. Of course, it doesn't work. We start debugging that bad student code. I'm not blaming them. I'm just saying when you take something online, a lot of the time you are going to spend a lot of time getting it to work, and it's not actually better than what we had before. So it's running, I think, about 40 times slower, but it's not doing anything better than what we had in the past. So we can try tuning BERT. I mean, this is what everybody's talking about. I was just outside talking to Milo from the Hebrew NLP initiative, and everybody are talking about tuning BERT. The downside is this is really slow. It's going to take up a lot of electricity. We've spent thousands of dollars on GPUs, and not sure that this is the right way to start your deep learning projects with text. Most of the upside is for AWS. Of course, those of you that prefer to make Microsoft or Google richer, matter of choice. So what's the alternative? So this is a nice piece of graphic from our good friends in Gong, where they suggest that if you have something easier rather than harder, you would have more success. So I don't know if you knew that before. So Schmid-Huber thought of another simpler solution. This is basically a sequence labeling problem. Why not use whatever people are doing in ACL? So we look it up, and people are talking that the state of the art is BILSTM CRF with attention. That's what they're comparing their BERT models to. And there's another Git. There is a link on the bottom if you need that. It's using character embeddings with word embeddings to train a BILSTM CRF model, and they're using that for neural sequence labeling, which is mostly NER and similar things. So some of you are going to ask why CRF. I'll address it later. The upside, this is training much faster. Code is much more easier to work with. The results are comparable to whatever we got from BERT. And you can iterate quickly. So I want this project to finish up in a good, timely manner. So we spend less research time building this. So what's the downside? I can't put a BERT picture here because no Sesame Street called BILSTM. So our next task, we wanted to add in ASR queues. This was already described in the first paper that I mentioned before, but we didn't have enough data. And it uses the gaps between the words, because if you're going to punctuate my text, there's probably a gap before you have a comma or a question mark. And when we look at the data, actually 90% of question marks have a stop after them. So people ask a question, even if they're going to keep talking, they do use some entrainment cues in their conversation to make sure that people understand it's a question, and these include pauses. So when we look at the data, we see that there is actually meaningful data there. We want to add this. It's very easy to add this as another character embedding. So we just add a character that's called there is a pause after this word. Tiny change for the LSTM model that I mentioned before. We just add one character, and already we have a model which is much better than what we had before with the Theano model. This is partly because it's trained on much bigger data. We are training with ASR queues. We are training on our own data, while the old model we trained on Europar. So first step, let's deploy it, finish up all the work. It's working faster, it's working better, so let's get our customers to enjoy this. Second step, I mentioned that we wanted to have more languages, so we want to go beyond English. Enterprise customers are asking for other languages. Not all of them need punctuation or use Western punctuation like Japanese, so we're not going to look at this right now. But most of the money is in Western languages. So French, German, Spanish have large populations of speakers, and a lot of businesses are selling to them. And the LSTM model works great. No need to start looking for BERT models. It might give you an extra %, but it's really, a lot of this is just evaluation noise. You need a lot more data and in-domain data in order to really test this. So I don't think that the difference is actually that real. So one curiosity point, for some reason, German is easy to punctuate, except on question marks, not asking enough questions. Maybe true. So don't worry, we are going to do BERT. So mostly because of this talk 3 weeks ago, I said, okay, but we never tested BERT thoroughly. Maybe we should go back to that. So some recipes, start tuning the regular BERT. After 5 days, we gave it up. We already started one of those new machines. It costs $4.50 per hour. It's running for 5 days. it's taking the time of someone from the team to feed it and take care of it and look at what's happening in there. Is it doing anything? Where is it going? So it's creating a lot of noise. So we gave up. Oh no. So this is Hugging Face. In case you don't know. I don't know what it shows here, but Unicode for Hugging Face. So we moved to the Steelbird, very easy to use with Hugging Face. Immediately, it goes out of memory. I mean, of course, after we spent a few hours training it. And we have to cut the data down to 126 words for the longest utterance. So we have utterances, speech utterances, which go on for 500 words, and the BERT model can support about 126 without getting too large. So we can still train it, but you know, we're getting into this sensitive zone that I'm afraid that we're missing out some things. Why 126 words? So we also have start and end characters for the utterances, and I'm going to mention that in the next slide. So it's better than the baseline BioSTM by little, but not better than the one with the pauses. And integrating pauses into the BERT model is slightly complicated. Also, it's 4 times slower than our BioSTM model, so it's going to cost us a lot more money to run this, and slower to run this while we're doing live recordings. So I don't know, maybe in the end of the recipe you see profit, so you can always test BERT, but I would not start with BERT, even though this is like the standard way that people do NLP nowadays. So let's dig slightly deeper into some of the points in the model. I looked up how to spell ablation in order to do ablation study, and turns out that it's like really, really nasty. So you take out parts of the animal brain in order to understand what makes it tick. But I guess with neural models, it's slightly nicer. So why do we need the CRF? That's the question that bugged me, because CRF is built for making sure that spans don't cross one another in a way that is wrong. Maybe the tags do affect one another. Maybe we don't expect to have a comma right before a word that is followed by a question mark. So in some settings, we got worse results without the CRF, and in some of them, it didn't converge, and I don't have a clear answer on why the CRF helps. It's using slightly different loss function than the model with the CRF, and maybe we need more tuning and we would get to the same results, but again, in a business setting, I just don't care enough to find out what the true answer is. Another thing that you can play with is the layer size. So the default in the Git package was 500. We tried 100 and 300. So the 300 one is 3 times faster, or 2.5 times faster. So it's going to save us even more money, which is like awesome. And having start and end of utterance labels really helped. Again, I'm not really sure why, but I guess it might be a PyTorch thing because they do a lot of padding inside. So back to the marketing, we're hiring for a bunch of positions. So if you have friends, send them my way. Any questions? Question mark.